by bin boundaries.
Yes, smoothing by bin boundaries. So we have this data, the sorted data, we are going to equally distribute the data. So we can have either 3 bins or 4 bins accordingly, because it is 12 numbers. So we can either separate 3, 3, 3, 3 like this, or we can separate 4, 4, 4 and 4 numbers. So for our convenience, we can choose how to distribute the data. So for us, let us just distribute the data into 3 bins so that it is easier for us, because many number of bins might be little confusing. So we just distribute our data into 3 bins. Now 8, 9, 15, 16 is in first bin, then 21, 21, 24, 26, it is in second bin, and the remaining 4 numbers in the third bin. So as what you have done yesterday, the same way you have to calculate for bin 1. You have to find mean 8 plus 9 plus 15 plus 16 divided by 4, which is equal to 12. So these bin numbers are replaced by the bin mean values. Similarly, for bin 2 also, you just calculate and replace the values here in the bin 2 by the bin mean values. So for second bin we got 23. So 23 is going to replace all these values. Similarly for the third bin also, you calculate the mean. So this is the mean value. This mean value is going to replace all these values. Now the third part, smoothing by bin boundaries. So smoothing by bin boundaries, here we have two intermediate values, right? So we have two intermediate values. So initially what we have done was we have only one intermediate value, and we have replaced the value by the nearest boundary value. Here also in same way we are going to do. So the first bin, let us consider 8, 9, 15 and 16. So 8 is the left boundary, 8 is the left boundary, 16 is the right boundary. So we have two boundaries here. Now you are going to check this 9. 9 and 8, which one is closer or nearer distance, or 9 or 16. So since we have two intermediate values, we are going to check this intermediate value with the two boundary values. So 9 is near to 8, right? So 9 will be replaced by the bin boundary 8. So it becomes 8, 8. But for 15, when it is compared with 16, we got 1, and when it is compared with 8, we got 7. So 15 is nearer to 16. So we will be replacing 15 by 16. So our new bin value will be 8, 8, 16, 16. So after bin boundary, we got 8, 8, 16, 16. Okay, so likewise, you have to do for the second bin also. For second bin, this is the value. Now you do some comparison. So these are the intermediate values, 21 and 24. These are the intermediate values. So 21 you compared with 21, exactly the same. So we will be replacing, just putting the same number value here for the intermediate, first intermediate value. For the second intermediate value, you check with 26, you check with 21. So 21 and 24, the distance is 3. 24 and 26, the distance is 2. So this 24 will be replaced by 26. Now our boundary values, our bin values are 21, 21, 26, 26. Okay. So this is how we replace with the boundary values. So finally, for bin 3, again you do the same thing. So you have two intermediate values here. 30 you check with 27, it is 3. 30 you check with 34, it is 4. So 30 will be replaced by 27. So our value will become 27, 27, 27 and 34. That is what I have written here. After bin boundary, our values of bin 3 becomes 27, 27, 27 and 34. The final value which is written here for bin 1, bin 2, bin 3 after smoothing by bin boundaries. So this is how we perform binning method. Now moving on, we have time dependent data. So time dependent data, these are nothing but the data which are collected over some period of time. For example, like last time also I have explained about this time dependent data, temperature recording. Temperature recording, then for example weather recording. So all this depends on time. Temperature recording, for example, every 5 minutes or every hour we are going to record the temperature, or even weather also every day we will record, or every morning, afternoon, evening we will record the weather condition. So it depends on some period of time, some amount of time, right? So that kind of data which is collected over some set of or some period of time is known as time dependent data. So number of sales per week. Okay, so every week the number of sales will be different. So this week, if our number of sales is around 10,000, next week it can be around only 5,000, and the other week it can be around again 7,000, like this. So this data which are recorded based on time, they are known as time dependent data. So here also same time series also, as you can see in the graph, down you can see your time interval, right? X-axis, which is a time period they have given here, April 1995, July 1995, October 1995. So April, May, June, July. So every 3 months they have taken they have done the record. So July, August, September, October, 3 months. From October, November, December, January, like this. So every 3 months they have recorded some data. Okay, some data they have recorded. This is the data for an industrial average. Dow Jones is the name of some industry. So for this industry, they have just uh, recorded the closing or some price or the number of sales they have done or the number of products they have manufactured, like that. Okay, so this is your data value and this is your time series. Okay, so x-axis is your time series and this is the data value to be recorded based on time. So this shows our time series. So here also they have explained about the graph daily closing values. So actually this graph shows the daily closing values of Dow Jones industry. So for this particular Dow Jones industry, they have recorded the daily closing values and a 200-day moving average. So we already know what is the 200-day moving average. So initially we have done about 3 moving average, 4 moving average, 2 moving average. So here, since it is a court of period of 1 year, because from April 1995 to April 96 is quite a long time, right? So 1 year, 365 days. So they have done a closing value, daily closing values recorded with 200-day moving average. So x-axis is the unit of time, as I told you, as x-axis shows the time interval. So every 3 months they have recorded, and y-axis is the measured value. So this is the data observed, recorded value. So time series we can represent as T(1), T2, T3, so on it until Tn. Okay, so where Tn is the most recent value. So this the value recorded here in Tn will be the most recent value, or we call this value as current value. Okay, current value. So now say an instrument reading is recorded every x unit of times. So every x unit of time, we have recorded the instrument reading, just like temperature reading. Sales of a product or error messages on a network, they can be recorded as transactions. Number of transactions during specific time interval, they can be recorded. So this shows some time series of values, right? And here we have time series with a window size 5. So that means nothing but leg time, which counts 3, or if the window size is 3, the time unit will be 3. If the window size is 5, the time unit will be 5. So here T4, T5, T6, T7, T8. So the time unit is 5. So our window size is 5. So considering the series, see here, there can be number of transactions and number of features. So number of transactions, here we have 5 number of transactions, we have 5 number of features and goal. So you see the flow here, you see the series here. T0, T1, T2, T3, T4, T5. So T5 is nothing but your goal. So the most current feature is, if you consider as T4, then Tn. Your goal will be Tn plus 1, right? So your, say suppose if T of n is the current value, then Tn plus 1, this t should be small anyway. Okay, this will be our goal. Okay, like this, T1, T2, T3, T4, T5. Here also you can see, if T5 is the current value, then T6 will be your goal value. So like this shows your time series, where we have a time lag of 5 time units. Okay, 5 time units, 1, 2, 3, 4, 5. So our time unit is 5, or we call as window size of 5. So here also it is written here, check the goal is to forecast Tn plus 1 from Tn. So Tn is nothing but your most recent value or the current value, and Tn plus 1 is the goal. A case is a feature, say, okay, so this is nothing but, when you say a case, then it will be a ordered pair. That means two values will be there. So Tn minus 1 and Tn. Feature and goal pair. So feature will be one value lesser than your goal value. So if goal is Tn, then obviously the feature will be Tn minus 1. Or you can just write, you can just write your goal, feature goal pair as T of an A. What happened? T of n along with T n plus 1. So these things can also be, Tn plus 1. This thing can also be the feature goal pair, because we consider this as a feature and this as a goal. Similarly, here also we consider this as a feature and this as the goal. So like that, goal feature goal pair can be represented either in this way or this way. Okay, so the time series can be translated into some other five cases, because we have window size 5. So there we can have 5 number of cases, and separately we if we represent this part in a spreadsheet format, it will be like this. Okay, so sometimes window size of 5 and some time series may be given, where you can uh, represent the time series into a spreadsheet format. So it is the spreadsheet format, this is the time series format. Okay, so this is what it is said here. So our window size of 5, that series can be translated into 5 cases in our standard spreadsheet format. Okay. So now iterative data preparation model. In iterative data preparation model, it is you have some kind of loop, right? Because since it is iteration, we are going to repeat some steps. So once we prepare the data, after preparing the data, what you have to do is you have to apply prediction methods. Applying the prediction methods, then you, if the result you obtain here is the final result which is optimal, then you can stop. Otherwise, you can perform the change method parameters. You can change some method, apply the prediction, then like this, one loop will be there. Okay. So,
Ma'am,
yes.
ma'am, some students are trying to enter.
Okay, okay, okay. So some parameters you need to know while calculating the time series. So T of I or T of N, this will be your current value. Then this will be your goal. Just now I have explained here, right? The same thing. We have written down here again. Current value is T of I. Our goal value is Ti plus 1. Then the goal difference. Sometimes you may be asked to calculate the goal difference. In that case, T of I plus 1 minus T of I. This will gives the goal difference. Then the ratio you can find for the current value and the goal. It is given by Ti plus 1 or N plus 1 divided by Ti. This will be the ratio in percentage. Okay. So when you calculate in percentage, you have to multiply by 100. So that gives you the ratio of the current value and the goal value. So moving average we have done earlier in your chapter number 2. The same thing. I'm not going to repeat once again here. Next one is text mining. Text mining here. We have certain steps in text mining. So the steps are here. Actually, text mining is nothing but this is a data preparation task where we will be using some input text data, and that input text data will be converted into a suitable format for data mining process. The first suitable format is for other data, it is a spreadsheet format. For the actual data also, we will be converting our text data into a suitable format for the mining process. Okay, so the data preparation task is required to reformat the provided input text. So this is what it is said. Just give me 1 second. defining, we are going to reformat the text, the input text data into a suitable format for data mining pre-processing. Okay. So for that, we can process into a standard format. Standard format here also, we have to convert into a standard format. So some rules are here. From data warehouse, we will be having the sample text. The sample text, we are going to check the dictionary features. Then case measurement word frequencies will be checked. Then number of cases. We will check the number of cases. Finally, it will be converted into standard form. So these steps are nothing but this one. Okay. So data collect and pull text from data fields. So this is nothing but collecting our data from the data warehouse. Okay. Then preliminary features. So we are going to find out the most commonly occurred words or the frequent words. So find k most frequent words. So first you collect the data, then find the most frequent words. So whatever the words you are using it frequently, that we have to find out the frequency. How many times does it occur? That we have to calculate. And after that, we have to perform filtration. That means in order to remove the useless words. So extracted features are nothing but from the features or from the textual data. Those are frequently occurring words that you have to find out first. And from that, you are going to remove the useless words. Okay. So, like for example, if an, and occurs many times, or the, the occurs many times, and actually the and these are not that much useful words, right? Rather than the, say for example, you consider this. The process of mapping text to standard form are summarized as follows. If you consider this text, this is a data warehouse. You are collecting this. These are the most frequent words. For example, to, of, the, are. These are the words which is frequently occurred and used many times, but it doesn't give that much useful meanings, right? So this kind of words we will be removing while we perform the filtration. And after that, those remaining words becomes the extracted features. Okay, remaining J word becomes the features. So in the paragraph, in the document, you may have certain number of does, you may have certain number of, you may have certain number of to, you may have certain number of s, right? So all those frequent words which are useless, we can remove, and those remaining words will become the extracted features. Okay. Then after that, finally, number of cases. How do we check the number of cases? So we will check for each case if the most frequent word is occurred or not. That means, for example, in that particular case which you are going to check, we have to check if there is any presence of the extracted words, okay, which is frequently occurring and also which is extracted words. Okay, that is case measurements. Because here what you have done is you have calculated the most frequent words, and after that the useless words you have removed, right? So those remaining words becomes the extracted features. But now what we have to check is the remaining words are most frequent occurring words and also the extracted words or not. That means also the features. If it is the features or not, that you have to check in case measurements. Okay. So once again, let me repeat. So for textual data also. Text mining is nothing but it deals with your text data. Your input will be your textual data. So in textual data, like in numeric data, what you have done, you have any raw data, as I told you in the beginning of the class, we have to convert into a standard format, right? For numerical data, it is very easy to convert in a numerical format. Likewise, for textual data also, you need to convert into a standard format. And for mapping the text into standard format, we have some certain steps here. 5 steps, very important steps we are going to follow. The first step is to collect the data from the warehouse. Second step is to find out the most frequent words. Third step is to remove the useless words. And fourth one, from those frequent words, after removing the useless words, the remaining words becomes the features. Okay. And the last one is those features after removing the useless words, we are going to check if that is also the most occurring frequent words. So all this will be checked before mapping our text into the standard format. Okay, so with that, your chapter number 3 is completed. So we have seen about preparation of data. This is standard measurements we have seen. We have seen data cleaning, transformation. Reduction yet to see. Reduction we will study in a separate chapter. Okay. Reduction we need to see this in another chapter. Data transformation and cleaning we have seen. So cleaning, missing values, how to handle the missing values, all those things we have discussed in our earlier class. And data transformation, these 3 things we have discussed in our class yesterday. And today we have seen about second binning method, second type of binning method. And we have seen time dependent data. Okay, time dependent data where the data is recorded based on some certain amount of time or based on some period of time. And we have seen text mining. So I'll just give you a brief introduction about your data reduction, and we will continue that data reduction in your next class. But before that, I'll show you one assignment question. That question you have to take a screenshot and you submit as a hard copy. Okay, not a soft copy. I'll share the assignment. 1 second. So this is your assignment question. Okay. Can you see the screen? Can you see the screen?
Yes, ma'am.
Yes, ma'am.
Okay. So first question, you just check it. The values of attribute income are given in the following table. Map the income value of rupees 66,250 to the range of 0 to 1. So how will you do this one? Which method of normalization will you use? Which method you are going to use?
Min-max.
Min-max. Very good. So min-max you are going to use. So but here they have given the observed values. So from these observed values you have to find out what have you to find out here from this. From this table, what you are going to find out?
Mean of income attribute.
Yes, very good. So you have to find out not actually mean, but the minimum value you have to find out. Because what is the formula you told? It is min max, right? So min max in the sense the minimum value you have to find out and also the maximum value you have to find out. for question number 1. Okay, what I'm telling is for question number 1, you have to find out the minimum income value and the maximum income value. And after that, the VI is already given 66,250. So you map the income using the formula. So you have to map 62,250 into the range of 0 to 1. So first one is using min-max, and second one it is using G-score. And G-score, here also you have to find out for a VI value of rupees 55,000 using G-score, where here price in rupees are given. That means what are the values you have to find out in question number 2?
Mean and standard deviation.
Yes, very good. Mean and standard deviation you have to find out. And finally, using G-score, you have to map the income of, map this value, rupees 55,000. So note here I have given first find mean and standard deviation, then solve with G-score. So in exam, these things won't be given, right? Because for your understanding purpose only, I have given this one. So in exam, we are not going to give this values like this. Okay, so directly I'll give you the equation, and from this equation you have to solve it. Now question number 3. Smooth the data using binning method. So it is very easy. Binning method. You can equally partition the data into equal bins. So initially what you have to do, the data given here is unsorted data. You have to sort the data first. So you take a screenshot. I'm not going to share this question. Take a screenshot and okay, you can take the screenshot. And you have to submit me this when you come for your exam. Okay, first unit test. That is on Wednesday, next Wednesday. So you have so many time. Today it is only Thursday, right? Friday, Saturday, Sunday, Monday, Tuesday, Wednesday. So 1 week time is there. So you study up to what we have done yesterday's class, up to what you have done in our yesterday's class, and you submit the assignment for this also. Okay, on Wednesday. So write in A4 paper and like how you have done in our previous semesters. I think we haven't done any assignments, hard copy submissions and all due to this corona. So this time you just write your assignment in hard copy, A4 paper, solve it and submit it. So in your front page, you write assignment for data mining. Then you write your name, you write your submitted by, then write your name, write your roll number, semester, and submit it to me on Wednesday. Okay. So I'll take a roll call because data reduction. Okay, data reduction we will do tomorrow because now I will be moving. Data reduction we can do next week. The data reduction also it is very easy, but some small calculations like how we have in our data preparation, like that we have some small calculations that we will do in our next class. Okay, so I'll take a quick roll call.